This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
I'm going to work through Section A of the Paper F5 September 2016 exam. And Section A is the multiple choice section with 15 questions. And what I'll do, I'll break this lecture into 3 and I'll do 5 questions each time, just so it doesn't get too long. Just one general point before I start working through them. I'll go through them obviously in order, question 1, question 2, question 3, otherwise it'll get confusing. But make sure in the exam you appreciate 2 things. One is it's a question of speed. You know, you have 3 sections to the exam and it's vital you make a decent attempt at each section. And if you spend too long on section A, you won't have decent time to do sections B and or C properly. And secondly, the questions do vary. It's always the same, the examiner says this. Although all the questions in section A carry 2 marks, some are a lot quicker or easier, others are much longer. And it is vital you jump around. You know, if question 1 looks long, leave it. Do the others and then come back if there's still time. Or question 1, it's life cycle costing. If you know you don't know anything about life cycle costing, or you always get it wrong, then it's pointless spending 10 minutes on it. Leave it, do the others, come back later if there's time. If not, guess an answer. It's vital you hand in 15 answers to section A. There are bound to be some that you get stuck on, that none of the 4 answers available seem to be correct. Or come to the end of the exam and you're out of time. You've only done 12, 13. When there's a few minutes left before the end of the final end of the exam, you must go back and guess any section A answers you've missed out. Because guessing takes 10 seconds. And you may guess correctly. And alright, it may only be 2 marks, but if you would otherwise have failed on 49, those 2 marks obviously would turn it into a pass, or failed on 48, 2 marks would turn it into a pass. So I'm sorry going on a bit, but it is vital. The minute you find you're spending too long on a question, leave it, come back later. Anyway, let's run through the first 5. Number 1, I'll always look at the bit in bold first. It says, what's the budgeted life cycle cost per unit? So you know what it is you're looking for before you start wasting time reading the rest of the question. Life cycle cost, remember, we want to bring in all the costs over the life of the product and divide by the number of units to get the cost per unit. And what are we told? We produce a range of products. We've developed a budget for the life cycle of a new product, P, and the following table relates exclusively to P. So let's start listing the costs. For P, we've got design costs, a total of 800,000. We've got manufacturing costs. It's 20 per unit. How many units? Well, it says further down, production is 300,000 units. And so 300,000 times 20 is, oh dear, 6 million. Depreciation costs, 500,000. Decommissioning costs, that's closing down, but it doesn't really matter what they are. We want all the costs, 20,000. So far so good. However, there's something about machine hours, and it says below the total fixed production overheads are 72 million a year. So that's for the company as a whole. We're only talking about one product. Total machine hours are 96 million hours. And we absorb overheads on a machine hour basis. So what's the absorption rate? In total, there's 72 million overheads. In total, there are 96 million machine hours. And so the absorption rate 72 divided by 96 is 75 per hour. And so how much is going to be absorbed into our product? The fixed overheads. There's 300,000 units. Each unit takes 4 machine hours, and each hour is being charged at 75 cents. And so in total, what's that? $3 a unit, 900,000. And so let's hope I can get my arithmetic right. I get the total lifetime costs 800, 6,000, 500, 20, 900. I get a total of 8.22 million. And so the life cycle cost per unit, 8.22 million. How many units? 300,000, which comes to $27.40. Is that one of the answers? Yes, it is. The answer is therefore C. Two things before I move on. One is, I'm trying to write reasonably neatly, otherwise there's no point if you can't follow me. But remember, in the exam, for the multiple choice questions, nobody will look at your workings. You'll need workings. I don't think you can do all of that on your calculator without writing anything. So you can do your workings in the answer booklet, but don't waste time being pretty. You know, there's no need in the exam to keep writing the description and so on. Nobody's going to look at it. And so, however long I'm taking, because I'm trying to write it neatly and I'm talking through it, in the exam, it's got to be as fast as you can. Anyway, there we are. Oh, and the other thing, sorry. I haven't got the examiner's answer in front of me. I think she set it out slightly differently. Irrelevant. You know, my answer's right. Set it out any way you like. It's just important you know what you're doing. Total costs over the life divided by total units. And the only extra, what you might call trick here, is this absorbing of the overheads. Anyway, let's move on. Number 2. A company makes and sells product X and product... Oh, sorry. I'm missing my own point. Always look at the requirement first. What is the total number of units which must be made and sold to make a profit of 45,000? Go back. A company makes and sells product X and product Y. Twice as many units of product Y are made and sold as that of product X. Each unit of X makes a contribution of $10. Each unit of Y makes a contribution of $4. And there are fixed costs of 90,000. Well, it should hit you immediately, since its contribution figures were given. We know the fixed overheads, the fixed costs, and so we need to say what total contribution do we want? Well, for a profit of 45,000, we need a contribution, the profit before fixed costs, of 45 plus 90. We need a total contribution of 135,000. What about the units? Well, if I let X equal the number of units of product X, it says twice as many units of product Y are made. So how many units of Y? If it's twice as many as X, surely it's 2X. And so what will be the total contribution if it's X units of X and 2X units of Y? Each unit of X gives $10, so X units, in total 10X contribution. Each unit of Y gives $4. Yes, $4. So if there are 2X units of Y, it'll be 2X times 4, or 8X. And we want the total to be 135,000. And now it's simple algebra. Add them together, 18x is 135,000. X, therefore, 135,000 divided by 18 is 7,500. We're not quite there yet, because and there's the danger. 7,500, oh look, it's one of the answers. But appreciate it wants the total number of units to be made. X is the number of units of X. We make twice as many of Y, so twice that, 15,000 of Y. And therefore, how many units in total? 22,500. So the correct answer is B. All right, next one. Watch me here, because if I remember rightly, you can save a bit of time. What is the material's yield variance for March? So you should have learnt all your rules about mixing yield variances. They want to know the yield variance. Now, there are several ways you can get the same answer. I'm not going to do several ways here, it doesn't matter. Because remember, nobody will look at your workings. But what's happening? On the standard cost card, I'm not going to set up the whole table, but how many kilos of materials should we be using per unit? 5 kilos of J, 2 kilos K, 3 of L. So a total of 10 kilos per unit. And how much in total should they cost, assuming we're mixing properly and pricing properly? 10 kilos should cost us, well, add them up, 20 plus 24 plus 24, yeah, 68. So that's what should happen. Every unit should use 10 kilos. And the average cost per kilo, if it's 68 for 10 units, it should be $6.80. Now, we're only after the yield variance. So for the yield variance, effectively, it's as though all the costs are as standard and the mix is as standard. And so let's look what actually happened. We produced 3,000 units. The actual usage in total, 13,200 plus 6,5 plus 9,3. 13, 19, 7, 28, I think 29,000 kilos. So that's how many kilos we should have used. Sorry, I beg your pardon. That's how many kilos we actually used. If everything had gone perfectly, how many kilos should we have used? The standard total usage for the actual production. Standard total usage for actual production. We produced 3,000 units. And I wrote down a minute ago that each unit should in total have used 10 kilos. We should have used 30,000. Well, now, in fact, I think I can have the answer immediately. Because first of all, it's 30,000 kilos we should have used. We only used 29, so we used less than expected. And so it's a favourable variance. And look at the choices of answer. If it's favourable, it's either A or C. And if you needed to, if you got stuck, guess. It must be A or C, and you have a 50% chance of getting it right. However, what about the amount? Well, we used 1,000 kilos less than we'd expect. Well, look at the choices. The two favourables, one's 1,000 and one's 6,800. Well, it's hardly going to be 1,000. That's to try and catch you, that you get 1,000 kilos and forget that it's not in dollars. So it must be 6,800. And in fact, it is, because we've 1,000 kilos less, assuming correct price, correct mix, which we do for the yield variance. The average cost per kilo is 680. And so the variance, 6,800, and as I've already said, it's favourable. So the answer's A. Next one. And here's one I don't really need to talk through. I mean, I'll talk through the actual question, but this is what I call a written question, in that there's no arithmetic involved. And I'm afraid here it's just a question of having read our free lecture notes or read your study text. But it's a very quick one. These actually are ones to go for, because it's very short. If you know the answer, tick it. Or these are ones where if you don't know the answer, you know it. So why waste time? You read it 20 times and you're not suddenly going to have a brainwave. If you know you don't know the answer, then guess. But what does it say? Which of the following is not likely to be a potential benefit of introducing this system? What system are they talking about? A management and retailer of kitchens introduces an enterprise resource planning system. Well, I've said it's really up to you to go back and read if you're not clear, although it doesn't actually, the word almost helps you. It's a planning system. Which of the following is not likely to be a benefit? Well, A, schedules of labour, they're plans. It would help there, planning. Inventory records are updated. Again, it's planning our inventory. Sales are recorded into financial ledgers. It's planning. Critical information can be summarised. No, it's not D. The place where we can summarise critical information and get overviews of things is the executive information system. That would be an advantage, a benefit of executive information. It's not a specific benefit of enterprise resource planning. Finally, for this little section, number 5, another one where if you've read the notes or read a study text, it's a question of learning. And there's not much else I can say. It says, what is this technique known as? Well, go back and read. Different management accounting techniques can be used to account for environmental costs. One of these techniques is analysing costs under 3 distinct categories: material, system, delivery and disposal. Well, I'm not going to have a lecture on environmental costs here. It's in the course notes. But those 4 that are listed are all techniques that could be used. The one that looks at those 3 categories is flow cost accounting. The answer again is D. But although I'm repeating myself, bear in mind what I said before, those 2 I think are ones to do almost as soon as you open the paper, because they don't take long to read. They're ones where there's no arithmetic involved. They're ones where, without spending more than a minute or 2, you know whether you know the answer, and if you do, tick it, or you know you don't know the answer, in which case guess. Anyway, all right, that's the first 5. I'll break this lecture. The next lecture I'll do the next 5.